Hi, today you're going to be learning about the terms longitudinal wave, transverse waves, and the different types of waves in general. So waves come in different types of things. Um, so first off, we got to talk about what is a wave. First, a wave is a disturbance or back and forth motion in a medium that transfers energy from one place to another. But then we use this word medium. What is medium? Well, medium is the material that the wave travels through. So in art, you ask an artist what their medium is. It's asking them what is the material in which they use. Are they a clay? Are they a potter? Are they charcoal? Do they do color pencils? So it's the material which they use to do their art. The same thing is true for talking about in physics. The medium is the material the wave travels through. So when you take a material, like let's say water, make a disturbance on it, slosh it back and forth, or blow on it, you're going to cause it to have a wave. So let's name some. You got ocean waves. So what is that medium? And you would say the ocean, the water. Sound waves. What's its medium? Well, that's air. Now, there are other types of waves out there. The two main types of waves are first your mechanical wave and your electromagnetic wave. Mechanical waves is what we're going to focus on in this unit. Electromagnetic waves we will deal in our next unit. So our next test will be on just electromagnetic waves. Electromagnetic waves is just another word for light, and we will have an entire unit on just light. So just know that the waves, we're going to have mechanical waves and then electromagnetic, and we'll go over electromagnetic later. Now, mechanical waves, this is moving of material. So we're taking something and we're going to move it, whether that being the air, whether that being the ocean, whether that being the actual earth itself. It really doesn't matter as long as it's moving a material. Then you have, but how we move it changes what kind of wave it is. If you are moving it in a transverse wave, or what we call a shear wave, that's your traditional, what you would think a wave looks like. That's your ocean waves. If you do longitudinally, or a compression wave, that is sound. You have this third one, which we're not going to go into, which is called surface waves, which was a combination of transverse and longitudinal. It kind of does circular motions. We'll go into it a little bit more. So transverse wave is taking a slinky and wiggling it up and down in that kind of fashion. The particles, the little atoms, are moving up and down perpendicular to the direction of the wave's travel. The wave is traveling down this way. So you can think of a string, a rope, a slinky, and you go up and down. It's going to travel along this path. It's going to go down the slinky. Your particles are moving up and down. So kind of like this example, where that little black dot moves up and down, the direction of the wave is going this way. This is known as a shear wave or a transverse wave. Ocean waves are this way. On the other hand, you have longitudinal waves. Longitudinal waves move back and forth. They have what is they are compression waves. If you take a slinky, and if you were not in class for this, take a slinky, specifically a metal slinky works the best. Stretch it out with one person holding it on one side, another person, and then grab a few coils, pull it together, and let go. You'll see this compression moving along down the same direction until it hits the other end, and then will actually come back. This compression wave and the opposite of compression, which is rarefaction, is going to move along. This is longitudinal wave. Longitudinal meaning it moves in parallel or in the same direction as the wave travels. So again, here's an example of this. As it moves along, the little black dot gets squished and pulled apart, and it causes it to squish and pull, and it moves this way in the same direction. Sound is this wave. As you speak or listening to my voice, the sound is actually being compressed and pulled apart at a very specific frequency. And that, in turn, talks about what we think what we hear as sound. So longitudinals will decompress and compress back and forth. In your eardrum, that sound, that compression wave, pushes on your eardrum in. The decompression, that rarefaction, pulls your eardrum out, in, out, and then it hits your inner ear, which then causes your inner ear to actually, your brain then interprets that back and forth motion of your eardrum as sound. Now, there are other waves out there. We're not going to go into them, but there are love waves, there's Rayleigh waves. This is kind of that surface wave. We're not going to go into it. But in seismic waves, when the wave goes through the earth itself, we call that an earthquake. Now, if it's a P wave, it's a compression wave, where it travels through the earth, compressing the earth, pulling it a little bit apart. The S waves move up and down. The interesting fact is that a lot of people think this S wave, the earth moving up and down, is the most dangerous. In fact, it is not. If you're in a building, the building is just literally just going to be lifted up and lifted back down, go into the valleys, and the earthquake's over. Not much disturbance. It's going to cause things to fall off your shelves, but it won't hurt you. This P wave, on the other hand, is where damage happens. Because what happens is this wave comes in, crunches your foundation of your building, opens up, and then you have no foundation anymore. And unfortunately, for most earthquakes, this is your primary wave, hence the name P. So what happens is this comes in few milliseconds or even seconds before, compresses the foundation, opens it up. Now you don't have a foundation anymore. Then this secondary wave comes in and lifts your building. Now you're not attached to the earth. So your building will now be levitated straight up and fall back down, and your building has no foundation, and that's what causes the buildings to fall down. So what I would recommend is finding a slinky from a friend or a sibling, or one that you had when you were a kid, and practice looking at these different types of waves, transverse, longitudinal. Play with a slinky, kind of get to know that idea of what longitudinal and transverse waves are. And if you have further questions, ask your teacher. Thank you.